Hey everyone, and welcome. So, have you ever really stopped to think about what makes a brain smart? We tend to imagine it's all about raw horsepower, like having a faster computer than the next person. But what if the real science tells a completely different and, frankly, a much cooler story? Okay, let's get into it. So, here's the question that's been bugging neuroscientists for ages. It seems so simple, right? If you're smarter, things feel easier, so your brain must be, just cruising along, not breaking a sweat. It feels like common sense. But is it actually true? Well, this very intuitive idea actually has a name, the neural efficiency theory. And for a long, long time, it's been the go-to explanation. The analogy is just perfect, right? A high-performance engine that gets way more mileage out of less fuel? The theory says that's exactly what a smarter brain does. It's just more efficient. But, and this is a big but, here's where this simple, elegant theory starts to fall apart. See, when scientists actually tried to prove it, they pretty much hit a brick wall. So let's take a look at why this super popular idea might be less of a fact and more of a myth. For years, decades, really, study after study came out with this just jumble of confusing results. I mean, some studies would say, yep, smarter brains work less. Others would come out and say, nope, they actually work more. And then a bunch found no connection at all. It was a total scientific mess, and nobody could really agree on what was going on. So what was the deal? Why was all the evidence so completely unreliable? Well, the answer really comes down to how these studies were being done. It was this classic statistical puzzle that was just waiting for a new, better approach to finally get it solved. You see, a lot of those older studies had two really big problems. First, they used these tiny sample sizes. We're talking fewer than 100 people sometimes. With that few participants, it's really easy for a couple of weird brains to throw off the entire result. And second, the statistical methods they were using, well, we now know they were much more likely to find patterns that weren't actually there, like seeing a face in the clouds. This new study, though, is a total game changer, with a massive sample size and way more solid stats. And when I say massive, I mean it. The difference is just staggering. 1,235 people. A study on this scale gives you such a clearer, higher resolution picture of what's really happening. It lets you filter out all that statistical noise that was messing up the earlier research, so you can finally see the true patterns. All right, so with this incredibly powerful new study, what did the researchers actually do? Well, they had all 1,235 of these people work on a memory task, and while they were doing it, they watched two really important networks inside the brain. Just think of it like this. Your brain has an action team. That's a network of regions that totally lights up when you need to focus on something. But then you also have a daydreaming team, which is doing its thing when your mind is wandering. That team usually powers down when it's time to get to work. So the big question was, how do these two teams act differently in people who are more intelligent? Okay, you might want to buckle up for this part, because this is where everything we thought we knew about smart brains gets turned completely upside down. The results from this huge study were not all what anybody was expecting. The first big shocker was that the overall connection between brain activity and intelligence was actually pretty weak. Basically, all those strong connections that the smaller, older studies had reported, they just kind of vanished when you looked at them with more powerful and reliable statistics. They just weren't there. And here it is, the real twist. The key difference in more intelligent brains wasn't that they worked less hard overall. It's that their entire brain state changed less when they were faced with a challenge. Okay, let me break down what on earth that actually means. So here's what was happening. The action team didn't have to ramp up as much to get the job done. But just as important, the daydreaming team didn't have to power down as much either. The whole system just stayed closer to its normal resting state. It's as if the task felt less disruptive, causing less of a fuss in the brain's overall balance. It's a sign of stability even when it's under pressure. But there was one last absolutely fascinating twist. One single area of the brain completely broke the pattern. This one region, which is kind of like the brain's master planner for organizing complex moves, it actually worked harder in the more intelligent subjects. This points to a totally different, more strategic way of solving problems. So where does that leave us? Let's put all these pieces together and build a brand new model for what a smart brain is really up to. So it looks like we've got a new three-part model for intelligence. First, smart brains maintain stability. They're less rattled by a task. Second, they pull this off by reducing the overall effort in most parts of the brain. But third, and this is the secret sauce, they strategically tell that key planning center to work harder, guiding the whole operation way more effectively. And this brings us to the huge takeaway. What this incredible study is telling us is that intelligence isn't just about having a bigger, more powerful engine. It's about having a better driver behind the wheel. It's a mix of stability, efficiency, and knowing exactly when and where to hit the gas. In other words, it's all about strategy. I mean, this completely reframes how we think about being smart, doesn't it? It's not some fixed amount of power you're born with, but a dynamic, strategic process. And that leaves us with one final, fascinating thought. If we've been getting something this fundamental wrong for so long, what other incredible secrets is the brain still hiding from us?